Today we will study center of mass of a body. What is center of mass of a body and what is its significance? Start. Suppose this one. This is rigid iron wire, heavy weight. It's Reynolds ball pen. See here, it balances. Can you guess the center of mass of this body at which location? It can balance here also. See. Observe this. I think 90% of mass this system is concentrated here. So this point and center of mass both are linear and vertical direction. So Earth tries to pull in this direction. See, okay, this one. The center of mass of a body is the average position of all the mass in the body. It is the point at which the entire mass of the body can be considered to be concentrated for the purpose of analyzing linear motion. This one is very important. The center of mass of the point where the body balances perfectly if supported. Definition, the exact definition, the center of mass of the system of n particles. M1 R1. R1 is the position vector of the first particle with respect to given reference frame. M2 R2 plus and so on Mn Rn upon M1 plus M2 plus and so on Mn. Significance of center of mass of a body. If a force is applied to a body, then acceleration of center of mass is given by F by M, no matter in which direction force is applied. If we want, if we are interested for linear motion only, acceleration of the center of mass of the body is given by F by M. If F is not passing to the center of mass, then it creates torque also, but acceleration of center of mass remains same. Where did this definition of center of mass come from? Now I am giving mathematical proof, analytical proof. Consider the system of two particles M1 and M2 separately, independently, and this particle is experiences force F1 and this particle experiences force F2. Both the force we are considering constant. So for the system of two particles, the total force is given by F1 plus F2, and it is M1A1 plus M2A2. It is M1 into dV1 by dt, well, rate of change of velocity of first particle, plus M2 into dV2 by dt, equal to M1 into ddt of V1. V1 is the rate of change of position, so dR1 by dt, plus M2 into ddt of dR2 by dt. So it is d square R1 by dt square, but Mr is constant, so we can write inside also. So d square by dt square of M1 R1 plus d square by dt square of M2 R2. F. So d square by dt square is M1 R1 plus M2 R2. F is M. The M is the total mass of the body, and acceleration multiplying this term by M1 plus M2 and dividing by M1 plus M2. So M1 plus M2 into d square by dt square of M1 R1 plus M2 R2 upon M1 plus M2. But M1 plus M2 is total mass, so this term and this term cut out. So this is acceleration. But acceleration of what? Acceleration of this point. This is the position vector. By dimension is the position vector. So which is the position of this? M1, M2, not. The center of mass of the M1, M2 system at that time. So acceleration of center of mass is d square by dt square of RCM. So RCM is nothing but this M1 R1 plus M2 R2 upon M1 plus M2. It is the position vector center of mass for two particles. We can define for M particle also. But do you know in the formula for work W is F dot D, where F is the applied force. But what is D? Displacement of what? Body? Not. It is the displacement of the point where we are applying force. I am giving an example. Suppose we are in gravity free space. Gravity is not there, but inertia is there. consider two identical discs of mass m and radius capital R. These two. One is, this cord is connected with center of mass, and this string is overlapped, wound on this disc, and this end is here. These two ends are at same vertical location. Suppose if we apply same force, this body and this body, we are applying same force. According to the definition, acceleration of center of mass is given by F by m. Acceleration of center of mass is capital F by m. So acceleration of center of mass for both the disc remains same. But here we are applying force at the center of mass. So there is linear motion only. But here the string is wound around the cylinder disc, and we are applying force here to the string, this end. So it rotates only, displacement only. But after certain time interval, if this disc is reaching here, then this disc is also here, because of acceleration of center of mass remains same. But if we want to maintain this force, we have to run, otherwise slack in the string, string becomes slack. So this end is not here. For this it is connected with the center of mass. So after reaching this disc is here, this end is here. But for this will rotate this way also. So a string opens. So this end may be here. And this is the extra displacement. See this one. So extra displacement of this point, this. So for this, if you want to find work W, W2 is half mv square kinetic energy plus rotational kinetic energy. And for this, W1 is half mv square. But if you want to find the total work done directly, so in this case, we are applying force here and finally the end is here. So we have to consider this much of displacement from this point to this point. If we take this displacement, then work W is F dot d dash this displacement, and it exactly gives this much, half mv square plus half I omega square. And in this case there is no rotation motion, so work W is F dot d. So here this end to this end, that is this center of mass to this center of mass, displacement is something smaller. But in this case, if we consider actual displacement of the point where we are applying force, this point. Now this point reaches from this point to this location. So we have to consider this much of displacement. And if we consider this much of displacement F dot d, we get this total work. So after d, they both have same linear speed, but the second disc rotates also. So torque tau is Rf, R cross F. R is the radius and F is the force. We are applying tangential force. But torque tau is I alpha for rigid body. I is moment of inertia, alpha is angular acceleration. But here for disc half mr square, moment of inertia, alpha is angular acceleration. So I alpha is Rf. So alpha is Rf by I is half mr square. So 2f by mr. So using 2 alpha theta is omega square minus omega naught square after t equal to 1 second, suppose. So 2 alpha is 2f by mr into theta omega square minus omega naught square. But suppose the system is at rest in initial condition, so it is 0. So this one omega square. But here omega is omega naught plus alpha t, and we have taken photograph after t equal to 1 second. So omega naught is 0 because system start at rest from rest, and it is 2f by mr into t is 1. So omega is 2f by mr. Omega is 2f by mr. Here omega cut out, after cut out, omega is 2f by mr, and subjecting theta, we get this one omega by 2, that is f by mr. So in comparison of this end extra displacement displays extra, how much? Then it is this much angle. So for 360 degree the distance is 2 pi r. So for f by mr degree, how much? So 2 pi r by 360 into f by mr. This is the extra displacement of this end of the second disk. Now, what is center of gravity? They are something different. Center of mass and center of gravity is different. If the gravity is uniform, acceleration is uniform, then center of mass coincides with the same center of gravity. So RCG is 1 upon W. W stands for weight. Integral R is the center of mass. Position vector of the mass element. Rho R into dV. Rho is the density at location R. dV is a small volume element, and G at R at that location G is this. So 1 upon W integral R gr dm. If G is uniform, then center of mass of the body coincides with the center of gravity. But if G is not uniform, they may differ.